Hello everyone, I'm Jay Joshi and welcome to the 27th episode of Learning Java. Today we'll be learning about exception handling. So first of all, what is an exception? So you all know what runtime error is, right? So when you're running a program and the program ends abruptly because of some error which was not during the time of compilation, it's a type of an error which you have to anticipate while writing the program. So a runtime error can basically be something like you divide a number by zero, or the user enters a string where he's supposed to enter an integer, or you access a index of an array which is out of bounds. Let's say an array has a length of 3 and you access the index 10. That's not possible. So this is a kind of a runtime error which causes the program to end abruptly. Now, this is not always good because obviously the user can make some mistakes, you can make some mistakes, and there's always a possibility of a runtime error. It's difficult to anticipate these kinds of errors. So, this is why there's something called exception handling. So, exception is basically a runtime error, and exception handling is basically solving those runtime errors. What will we do when a runtime error occurs? So, this is what exception handling is. So whenever there's a runtime error, it won't like prevent a runtime error. Exception handling is something which happens after a runtime error happens. So let's say a program is running and the program encounters a runtime error. The program will not end abruptly. What will happen is the exception handling will handle the error. So this way the program won't suddenly crash and it won't leave the user confused. It'll gracefully die. So it'll handle the program a bit to do what happens if a runtime error happens. For example, let's say I'm a user and I'm let's say using a program and I'm supposed to enter an integer value and I enter a string. If there's no exception handling, the program would just end abruptly, leaving me confused. But if there's exception handling, there can be something like if this runtime error happens, then it can display an error message saying, "Oh, you entered a string where an integer was supposed to be entered." So now I know what the problem is, so I can run the program again. So this is why exception handling is useful. It's a very important thing which I would recommend you all start implementing in your codes right now, because we'll be using exception handling in files, because in file handling, so basically files, you can there's lots of errors that can happen in file, lots of runtime errors. For example, you call a file, you try to open a file which doesn't exist, or you call a file which is already open, or you close a file which is non-existent. There are many types of runtime errors. So in file handling, this exception handling is very important. And even in your normal codes, it's a very good practice to have exception handling. So this is why this is a very important topic. Now, why is this important? What are the advantages? As I said, so first, it improves the readability of the code because it separates the code in which there might be an error and the code in which there might not be an error. Then again, it makes the maintenance and management of the code easy. If any other programmer is also reading your code, he will know where there might be an error. Then again, it enables the programmer to create like a clear program for anyone else to read or for themselves to refer to later on. And obviously it helps the user so that doesn't leave the user confused. It just prevents the program from ending abruptly when a runtime error is encountered. So what can we do to solve this exception error? What is exception handling? So as you know, there are many classes, and so the runtime errors, I told you there are many examples. So exception handling is basically the main class, the root class of the exception handling is called the throwable class. We have many classes like the math class, which has the math function, string class, string functions, character class with character functions. So the functions of exception handling are in a class called the throwable class. And under this throwable class, there are two types of classes, the error class and the exception class. Now, both this error class and exception class are part of throwable classes, so it's both exception handling. They both handle exceptions and they both have different functions. So, error class handles different types of errors, exception class handles different kinds of errors. So, error class is basically a class which handles errors which we have no control over. So error class is basically a class which handles errors which are beyond human control. For example, hard disk crash, or if the computer just runs out of memory. We can't control these kinds of errors because it depends on user to user. So the programmer has no control over such kind of errors. So to solve these kinds of errors, there's something called the error class, which I'll be covering in a later video. In this video, we'll be covering only exception class. Exception class is basically all the exceptions I told you. There are many exceptions like the runtime errors basically. So here's some of the examples. The arithmetic exception, an example of this is dividing a number by zero. Array index out of bounds exception, which if you try to access an array, the index of an array which is out of bounds. Same for a string. Let's say you're using string.index of or s.substring, and you access an index which is like more than the length of the string, then it'll cause an error. File not found exception, like that. There are many exceptions. So all this comes under the exception class. Error class, again, as I said, I'll be covering in a later video because these are beyond human control. Now, what comes under this exception class? How does the program solve this thing? So what comes under the exception class? So there are three main components, I should say, which come under the exception class: the try, catch, and finally block. So what is this try, catch, and finally? So the name, you can try to figure out something from the names. How they solve this runtime error? So let me explain right now, and then I'll show you a program to make you understand better. So the try block, so let me first tell you how do you implement these. So you don't need a separate package to invoke this try, catch, and finally. You can just nothing normal. You can just use this in your normal public static void main or any other function. You cannot use them in the class because you can't. Only in functions or public static void main. So first we look at the try block. So to invoke a try block, we can just do something like this. This is basically a try block. And all the lines of, so basically what we are doing over here is we write try, this curly brackets, open and close. And whatever comes inside, whatever the line of code comes inside this curly brackets is part of the try block. Now, what does this try block do? So this part of the code, which is inside the try block, is the part of the code in which you might anticipate a runtime error. So let's say I'm performing an arithmetic thing over here, arithmetic calculation, or I'm handling files over here. All this or any other thing, let's say I'm handling strings or I'm handling arrays, anything which has the possibility of having a runtime error, it's good to put it in a try block. So it's compulsory. So whenever you're using an exception class, you're supposed to put a try block because if you want to catch an error, you can catch an error only inside the try block. So if you have like 10 lines of code in which you can in which you anticipate a error or runtime error, you can put it in a try block with this parenthesis, and whatever is inside will be the error part of the code, the error handling part, which you're anticipating an error. Now, and also you can have multiple try blocks in different parts of code, that doesn't matter. Now, what is the catch block? Now, the catch block is what has happened if a error is found in a try block. So how do we use the catch? It's something like this, catch, and then we have a parameter over here, which I'll be covering in a bit. And then again, we have lots of code over here. Again, you can have multiple catch blocks like the try block. Now let's say I have this is the try block over here, and this is the catch. If I encounter a runtime error in this try block, the code, the line of code, the control will be transferred to the line of code in the catch block. Now, how is this decided? So this is the basic thing of a catch thing. It's the same as tries, just that there's some parameters in these basic brackets. This bracket is just this normal parenthesis. So what's the parameter? This parameter is basically what kind of exception. So if let's say I'm anticipating arithmetic exception, in the parenthesis, I'll put arithmetic exception and then a variable. Now, this is technically not a variable. This is an object. So this will come inside the catch block. So if I find if a runtime error is encountered inside a try block, if a runtime error is encountered inside a try block, the line of control will get transferred to the catch block, which has the parameters of an arithmetic exception if an arithmetic exception is encountered. You can have another catch block for a index out of bounds exception. Yes, you have to write this full thing. And over here, you can have another object, let's say a capital E. So these are just objects which you don't have to declare before, okay? So you just put any variable which follows the identifier rules for now. It's basically an object which you're checking as a parameter. So you put catch and then the parameter as the type of error you might anticipate. Now, a simple method, instead of just putting so many exceptions, you can just do something like catch, and then in the bracket, instead of like putting as a parameter all these big exceptions, you can just put exception, exceep. It's case sensitive also. You can see how all these letters are capitalized. So every different word has a different capital. I mean, the first letter of every different word is capitalized. Exception E. So this can be anything. Let's say I call this exception A. So if I write this as a parameter and this is my catch part of the code, if I do write this as an exception, any exception, so let's say any exception is encountered inside the try block, it'll just go to this one because exception. When I write only exception, it includes every single exception in Java. Arithmetic, array index out of bounds exception, string, file, any exception. So this is, I would say, a pretty good one to use if you're just starting out because this will just handle every single kind of exception. And this is an object which is compulsory. And parameters are also compulsory in catch block. Now, if you have a try block, it's compulsory to have a catch block because let's say you only have a try block and a runtime error is encountered. What will you do? Like, what's the point of a try block if it's without a catch block? Because you have to take some action if an error is runtime error is encountered inside a try block. So if a runtime error is encountered inside a try block, it transfers the control to the cache with that respective parameter, and it's only exception with the name of the object, it can just go with that. Again, you don't have to initialize this object separately. Now, what do we write inside the catch block? You can have any statements you want. You can just have another part of the code. You can just have a simple SOP statement, system.out.print, error, please enter the input correctly. Any type of error you want. It's just normal code you can have inside. If you want, now this is kind of different. This is perspective to perspective. If you want to use it, you can. If you want a technical kind of message to appear, you can use this command. So in this case, the object is A. This is important. You can use this command a dot get message. So G is small, M is capital, MESSAGE, and with open close brackets, and then this is the close bracket for this SOP. So this is open close brackets again. It doesn't look that great, but it's open and close brackets. So if you want a technical message to appear if an error is encountered, you can use this command. So that's the name of the object A. Over here, let's say if I use the technical message over here, it'll be E, small e, over here it'll be capital E. So the name of the object, in this case A dot get message. G is small, M is capital, casing is important because Java is case sensitive. So you can use this name of the object dot get message, open close brackets, and this will print a technical message which Java has already inbuilt. So this is basically it for the catch block. This is very important. Now we have the finally block. This block again is the same thing. So you write it as finally. Finally, this doesn't have any parameters, so it's just like this, and then you have your code over here inside these curly brackets. Now, what's the finally block? Now, unlike the try and catch block, which are compulsory, the finally block is optional. Now, the try block, as you know, will always be executed. Why? Because that's the normal code. It only exits the try part of the code if a runtime error is found. The catch part of the code is not always executed because the catch part of the code is executed only if a runtime error is encountered in the try part of the code of that particular exception which you put in the parameters. But the finally thing, if you have a finally, because it's optional, if you have a finally thing in your code, this finally, again, you can have multiple finallys, multiple tries, multiple catch blocks. If you have a finally in your code, this will get executed whether or not error is encountered or not. So let me run through the pattern again. Try block is always encountered, and I mean it's always executed. The catch block is executed only if there's an error in the try block, otherwise it's not executed. And finally is executed whether or not an error is encountered inside the try block or not. So the code can go something like this. You first it goes to the try block, error encountered goes to the catch block, whatever's in the catch block it prints that, and then it goes to the finally block, and whatever's in the finally it does that. In this part of the code, you can have again anything you want to do. You can print some statement, anything. So finally is always executed irrespective of whether an error is encountered or not. So that's basically it for the try, catch, and finally block, and this is how you handle exceptions. Now I'll be showing you a program code to make you understand exceptions better. Here I have a class called exceptions, and we have public static void main. Just ignore what the program's about. I'm just explaining the use of try, catch, block, try, catch, and finally block. Now, this program you can see doesn't have a finally, okay, because it's optional. It's usually, I don't prefer using it because you can just write the code normally, but if you want it, you can use it because it's just executed whether or not the try and catch is executed or not. So, this part of the code you can see over here, we are performing lots of arithmetic exceptions. This mod thing over here as well, there's a division over here. Now, if there's a division, there's a chance that this rem variable over here may be zero. So if you're dividing a number by zero, Java gives a runtime error. So if this rem is zero, just in case the user enters some particular value based on that, if x mod y turns out to be zero, then this is going to result in a runtime error causing the program to enter properly. But thankfully, this is in a try block. So you can see try, and we are predicting a runtime error over here. So if a runtime error is found over here, then it will go to the catch block. Now it depends on what kind of error. If it's a number format exception error, then it'll go in this catch block. If it's an arithmetic exception, which is division by zero, then it'll go over here. So number format exception is basically if the entry over here is invalid. So let's say because we are expecting a integer from the person. So we are actually using integer.parseInt. Ignore this for now, this accepting line, because I'll be covering this in a later video. This is actually a wrapper class. So just ignore the accepting part of this now, and even this exception. So if an arithmetic exception or any other exception is encountered over here, it'll directly go to this catch block or this catch block based on the type of exception. And then it'll perform this. So it'll make the Boolean variable flag false, and then it'll print this value. And then after that, so that's it for the catch block because the parenthesis end, and then it'll continue with the rest of the code. If there was a finally block over here, let's say if I have something finally over here, then all the lines over here will also be executed. And again, the finally, you can't have a finally without a try, and you can't have a catch without a try. So if you have a try, you need to have a catch. If you have a catch, you need to have a try, because try and catch are compulsory. Finally is optional. But if you have a finally, you need to have a try. And if you have a try, you need to have a catch. So if you have finally, basically you need to have try and catch. So this is the basic use of try, catch, and finally on how you can handle exceptions. Again, what I was saying, if you have just have this exception.e, this will handle the code again. So, and this is giving an error because the error will always go to this catch because it's handling all kinds of exceptions. It'll never go over here. So, because see, it says it has already been caught. Why? Because this handles every single type of error. So if an error is encountered, it'll go to this catch block, and whatever the exception is, it'll just execute this. And this will never get a chance to get executed because this error won't come. So that's it for a try, catch, and finally block and how you can handle exceptions. This exception class, just a reminder, is in the throwable class and is used to handle runtime errors. So that's it for today, everyone. Thanks for watching. And if you have any queries, doubts, or suggestions, you can mail me. My email will be in the description down below. And thanks again for watching.